In this video, let us continue to solve problems based on volume of cone. The question reads like this. A right triangle ABC with its sides 5 centimeters, 12 centimeters and 13 centimeters is revolved about the side 12 centimeters. Find the volume of the solid so formed. If the triangle ABC is revolved about side 5 centimeter, then find the volume of the solid so obtained. Find also the ratio of the volumes of the two solids obtained. Now, if you read the question again, it says that a right triangle ABC with its sides 5 centimeter, 12 centimeter and 13 centimeter is revolved about the side 12 centimeter. So that means we've got a cone like this. Now, how did we know that this is a cone straight away? Now, it is revolved about the side 12 centimeters. The right triangle ABC is revolved. So, if a right triangle is revolved around one of its sides, then the solid that we obtain is a cone. So, now we see that the longest side in this right triangle is 13 centimeter, which should be the hypotenuse. So, here we have 13 centimeter side here, which is the hypotenuse. This is also 13 centimeters. Now, we need to draw this axis here, which makes it a right angle, or which makes it a right triangle here. So this is 13, so this should be 12, and this is 5. Now why should this be 12? Because it is revolved about the side 12 centimeters. It is revolved about this one here. So that is why 12 comes here and 5 comes here. Now we need to find the volume of the solid so formed. Now we just have the information here, that is the slant height is 13, the height is 12, and then the radius of the circular base is 5 centimeters. Now they are also saying that if the triangle ABC is revolved about the side 5 centimeters. So how is this? So this will be something like this. So now this will be 13, this will be 5, this will be 12. Of course, the drawing, the way it's drawn, does not support this, but then this is just for the problem's sake. So this is 5 centimeters, this is 12. The radius of the circular base becomes 12 and the hypotenuse remains 13. Now we also need to find the volume of the solid when it is revolved around the 5 centimeter. It is revolved about the 5 centimeter line. Now after we find both the volumes, we need to just find the ratio of the volumes of the two sides that are obtained. Now let us start solving the problem now. So we need to find two volumes. Let's keep this as V1, let's keep this as V2. So V1, we have the volume of the cone is nothing but 1 by 3 pi r square h. So we have 1 by 3 into 22 by 7 into r here is 5. So it is r square, so it is 5 into 5. And we've got the height as 12. So cancelling this, we have 4 times 12. And this gives us exactly 100. 5 is 25. 25 into 4 is 100. Let us consider this 22 by 7 as just pi. So 100 pi centimeter cube. The reason I'm considering this as 100 pi is when we have to find the ratios, we eventually have to divide both the ratios here. So we can cancel the pi. So we don't have to complicate it by multiplying it with the expression. Now let us find the volume 2. The most important thing to consider here is that in the first volume, the right triangle revolves about 12 centimeters. In the second volume, the right triangle revolves about 5 centimeters, and that is why the 5 centimeter becomes the height and the 12 centimeter becomes the radius. Now we have V2 equals 1 by 3 pi r square h. So we have 1 by 3 into pi into r is 12 in this case. So 12 into 12 to height is 5. So we have 4 times 12. And then this gives us exactly 240 pi centimeter cube. So now we've got both the volumes. One is 100 pi centimeter cube and one more thing is 240 pi centimeter cube. So the ratios is V1 is to V2 will be equal to 100 pi centimeter cube is to 240 pi centimeter cube. So the ratio will be like this. V1 by V2 equals 100 pi centimeter cube divided by 240 pi centimeter cube. The centimeter cube gets cancelled. Pi and pi gets cancelled. 1 0 and 1 0 gets cancelled. Cancelling this, we get 2 5 times is 10 and 2 12 times is 24. So we have a ratio V1 is to V2 as 5 is to 12. So therefore, we can conclude that the ratios of the volumes of the two right triangles or the two cones, those are formed as a result of the revolution of the right triangles, about 12 centimeter and 5 centimeter respectively, are 5 is to 12. So this completes this problem. Let us solve another one. A cone of a radius 5 centimeters is filled with water. If the same water is poured in a cylinder of radius 10 centimeter, the height of the water rises 2 centimeter. So using this data, we need to find the height of the cone. Now, we have a cone here. We have a cone of radius 5 centimeters. So this radius is 5 centimeters. Now this is filled with water. Now the same water is poured in a cylinder of radius 10 centimeters. The radius here is 10 centimeters. So this should be a very big one. And also it is a cylinder which has got the same width throughout. So as far as this cylinder is concerned, when the water in this cone is poured into this cylinder, it just rises only 2 centimeters. So say something like this. There is only this much water. So this height is 2 centimeter. So now this volume of the cylinder should be equal to this volume, the entire volume of the cone. So using this data, let us find the height of the cone. The most important thing to remember here is this volume of the cylinder is equal to the entire volume of the cone. So let us start solving the problem. First of all, let the height that we have to find be h centimeters. And the volume of the cone is given by 1 by 3 pi r square h centimeter cube. So we have 1 by 3 into 22 by 7. The radius is given as 5. So it is 5 square, 5 into 5 into h centimeter cube. Now, the volume of this cone is equal to the volume of this water. Volume of the cone is equal to the volume of the water. So volume of the cone we have as 1 by 3 into 22 by 7 into 5 into h. And the volume of the water here is, it's nothing but we need to use the volume of the cylinder in this case, which is nothing but pi r square h. Now pi is 22 by 7. R is 10. So r square is 10 into 10. And then h is 2 centimeter because we just need the volume of the water only. So we are considering only this much of the cylinder here. We are not going beyond this. We don't take this one. So we just want to find the height of this one. So the h is 2. The formula that I'm using here is pi r square h, the volume of cylinder. So now equating this, we have 22 by 7 and 22 by 7 gets cancelled. And so we have, on solving this, we get height as 24 centimeters. So hence the height of the cone is 24 centimeters. So this ends this video, which consists a set of 2 problems.